Welcome back, and here's the last section of cell structure and function, and today we're going to look at the cytoskeleton and movement, cilia and flagella. So the cytoskeleton is the combination of microtubules, microfilaments, and intermediate filaments within the cytoplasm that gives the cell its shape and support. So the cytoskeleton will maintain the cell shape, and it allows cell movement and support. So if we look at the diagram right here, we can see this network of pipes and looks like almost strings, the microfilaments and intermediate filaments. So the cytoplasm isn't just this water. It's not like a water balloon. It's more structured than that because these filaments and tubules in there give it support, give it structure. So in class, and I'll have a link for you in your folder to the Inner Life of a Cell video. In there you can see this complex network that the organelles kind of get pulled along and move, so it really provides a highway within the cell. Now the three parts that make up the cytoskeleton are going to be the microtubules. They're the largest, and they're made up of this protein called tubulin. There are microfilaments, which are the smallest, and they're made up of a protein called actin, which we'll see in muscle as well. And then there's intermediate filaments that are kind of intermediate in size, and they're made up of a protein called keratin. The combination of these three give the cell its shape and structure. Now, related to those, there's the movement of the cell. And some cells, like the one on the left here, will be coated with very small hair-like projections called cilia. And they all kind of beat in unison to help it move. Whereas other cells will have one to several longer flagella that rotate like a whip and propel or pull the cells through the medium water in many cases. So if we look at the structure of them in the upper left hand, the flagella we see has a propeller-like motion. It moves around in a circular, whereas the cilia whips kind of back and forth in a beating action. So we can see now if we move down to the lower right, the cilia has this what they call a power stroke, where it whips along and then recovers, and the combination of many cilia working in unison propels the cell through the water or the medium that it's in, whereas the flagella usually either pushes or pulls by this rotating action, almost like an outboard motor. Now, both the cilia and the flagella have a similar structure, and here's what ties them together with the cytoskeleton. So if we look at this, both the cilia and the flagella are composed of microtubules arranged in what they call a 9+2 format. So if we look at the inside, kind of the cross section, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 what they call doublets of microtubules around the outside, and then there are 2 in the middle. So when they talk about this 9+2 format, this is what they mean, and this is kind of the ultrastructure of the cilia and flagella that help propel cells. So short and quick section here, but again, looking at the three components of the cytoskeleton, the microtubules, the microfilaments, and the intermediate filaments, and then the cilia and flagella, how they're put together and how they help propel cells through the medium that they're living in and make them motile. And that wraps up the cell section of this unit. And so thanks again for your participation.